In the early 2000s, the freshwater mussel was already considered extinct, but Scotland took a bold step and reintroduced hundreds of live adult mussels into 3 rivers, all bred from wild populations. The reasons for the decline varied. In some places, it was changes to the riverbed and the speed of the current. In others, it was silting of the riverbed. In still others, it was the disappearance of fish. And without fish, the mussel larvae cannot survive the first stage of their life cycle. Restoring the species meant restoring the entire river cycle. At first, nothing happened. Then the first signs appeared in the water, and the process that had been considered nearly impossible was slowly beginning to return. In 1967, Bill Abernethy found the largest pearl in modern Scottish history on the River Tay, 44.5 grains, the size of a marble. Before taking it to a jeweler, he wrapped it in a burdock leaf so as not to scratch it. The pearl had grown inside a living mussel for approximately 80 years, meaning it had begun forming during the reign of Queen Victoria. Abernethy died in 2021 at the age of 96. He was the last. Then began what no one acknowledged as decline, because each new generation of people along the river knew only what it had seen for itself. By 1970, enough mussels remained in Scotland for illegal pearl hunters to make a living. They would open them by the hundreds, leaving mounds of dead shells on the riverbanks, searching for that 1 in 5,000 that had formed a pearl. By 1998, when the mussel was brought under full legal protection, the species had already disappeared from 58 Scottish rivers. From 1970 to 1998, 2 rivers per year, methodically, like pulling bricks from a bridge. The mechanism of extinction is no secret. Mussels require several things simultaneously: clean water free of silt and excess phosphorus, and even flow uninterrupted by dams that alter current speed, and most paradoxical for a creature of the riverbed, young salmon or trout, because it is on their gills that the larva spends its first 10 months of existence before dropping into the sand and beginning to grow. For the first 5 years after detaching from the fish, the young mussel lives entirely beneath the sand, invisible, the size of a pinhead, dependent on oxygen in the spaces between gravel. If the substrate is silted, it suffocates before reaching the surface. If it survives, it begins to grow at a rate of roughly 2 millimeters per year. Sexual maturity takes 12 to 15 years. This means that every adult mussel in a river is the product of 15 consecutive years of perfect conditions. 1 bad year at any stage, and a generation never appears. As salmon stocks declined, so did the mussels. A mussel that might have lived 120 years and remembered the river as it was before the Industrial Revolution would die within hours of someone prying open its valves in search of that 1 in 5,000 chance. As water quality deteriorated from agricultural runoff, so did the mussels. As rivers were straightened with concrete banks for flood control, so did the mussels. Anglers who remembered the rivers of the 1960s said there was simply less fish now. Younger anglers thought that less fish was the norm. Both were telling the truth. Both were describing different rivers. To live to 100 years, as Margaritifera does, and to witness all these changes from first to last, is to find that extinction looks not like catastrophe, but like slow forgetting. When, in 2004, the Cairngorms National Park Authority and Scottish Natural Heritage announced a reintroduction plan, the reaction was divided along 2 clear lines. Engineers from the Hydrological Services raised a specific objection. The rivers proposed for mussel reintroduction had undergone significant modification in preceding decades, including channel clearance, bank straightening, and flood defense structures. A 2012 report recorded that regulated river sections showed substrate compaction. Gravel was cemented by silt to the point that a small mussel freshly dropped from a fish's gills has nowhere to enter. If juveniles cannot burrow into the riverbed within the first few hours after detaching from their host, they die. The hydrologists asked, what is the point of releasing thousands of adult mussels into a river if they cannot physically reproduce? The argument was logical and supported by data. Farmers from the riparian land raised a different objection. Reintroduction required restricting livestock access to the banks because hooves break up the soil and rain-driven silt slides into the water. For some holdings, this meant relocating hundreds of meters of fencing and losing part of the pasture closest to the water. Representatives of agricultural associations spoke openly in 2004 and 2005, saying an extinct mussel cannot be more important than working farmers. This too was not empty rhetoric. Scottish agriculture was genuinely under pressure. Farm consolidation, falling milk prices, and shrinking European Union subsidies made fencing requirements look like yet another regulatory burden imposed from above. Alongside the committee debates, something else continued. Poachers went out to rivers at night in summer when water levels dropped and mussels were visible through the surface. The law provided for a fine of up to £5,000 for each mussel killed. The average actual fine for fisheries poaching in Scotland was £349. Everyone involved in conservation knew the figures. In the autumn of 2004, it seemed the project might end before it began. Two committees in the Scottish Parliament were hearing objections, and funding from the Cairngorms Leader Plus program had not yet been confirmed. One public hearing reached a dead end. Participants left without consensus. Funding was confirmed in December 2004, a few weeks before the end of the budget cycle. Cairngorms Leader Plus provided a portion of the money, and the remainder was covered jointly by CNPA and the Dee and Spey District Fisheries Boards. The total budget for the first phase was not made public, but it was enough for one attempt on 2 rivers. Between 2013 and 2015, researchers from Scottish Natural Heritage conducted a full survey of all known Scottish rivers where Margaretifera had once been present. Standard methodology. Each section was assessed separately. The results were published in a scientific report in 2016, authored by Cosgrove and others. Of the 126 rivers surveyed, in 11, mussels had disappeared entirely. In 44, mussels were present but showed no sign of reproduction. Only old individuals, the youngest of them at least 30 years old. In 71, there were signs of successful recruitment. But even among those 71 rivers, 97 of the 115 populations present were classified as rare or sparse, fewer than 10 mussels per square meter. Only 18 Scottish rivers had common or abundant densities. One finding was unexpected even for the report's authors. The decline in populations since the first national survey in 1998 proved greater than conservative projections had anticipated. The number of apparently extinct populations had risen from 58 to 73. In other words, even after the mussel was placed under protection in 1998, a further 15 rivers lost it over the following 20 years. This is a stark decline. In one river in the Western Highlands, between 2 surveys 5 years apart, an entire mussel bed vanished completely. There were no storms and no recorded engineering works. Scottish Natural Heritage classified the event as significant and sustained criminal damage. Overall, 75% of all surveyed sites showed evidence of illegal interference. The researcher leading that region reviewed the data 2 days before publication and wrote a single sentence in internal correspondence. "This is worse than we thought." The report was downloaded 847 times in its first month, more than any previous NatureScot report on a freshwater species. Downloads were unusually high. In 2015 and 2016, researchers returned to 3 rivers into which adult mussels had been translocated between 2005 and 2009 from protected populations. The mussels used for reintroduction had not come from a captive breeding facility. They came from living wild populations that had survived in protected rivers. Every translocated individual was a mussel removed from a place where it was already surviving. Decisions about how many could be taken and from where were made on the basis of counts. Would the removal harm the donor population more than it would benefit the recipient? There was no answer to this question, only a calculation of risk. On River A, it became clear that the riverbed was unstable. Annual flood events scoured the substrate. Mussels survived only as isolated individuals. The hydrologists who said in 2004 that nothing would work without bed restoration had been right, at least for this site. On rivers B and C, the picture was different. The mussels had not merely survived. Monitoring of juvenile salmon gills showed the presence of Glochidia larvae of the next generation. The mussels were reproducing. The larvae were attaching to fish. The cycle had closed. But the most unexpected discovery was made where no one had been looking. Researchers taking water samples above and below the reintroduced mussel beds on River B recorded a difference in turbidity. The water downstream of the mussel colonies was clearer. Not meaningfully so to the human eye, but measurably. A single adult Margaritifera filters more than 50 liters of water per day. A colony of several hundred individuals processes tens of thousands of liters daily passed through a living sieve. No one had set out to clean the water. The cleaning occurred as a side effect of presence. Then they found something else. In the cleared sections, juvenile salmon numbers increased. Salmon are the host for mussel larvae in the first cycle. More salmon meant more chances for the next generation of mussels. The mussels were cleaning the water in which the salmon lived, the salmon that carried their young. The hydrologist keeping the observation log looked at the two graphs, the salmon trend and the mussel trend, and was silent for approximately a minute. In 2012, the Pearls in Peril project launched, a joint initiative funded by the European Commission and 22 organizations across the United Kingdom. By 2017, the project covered 21 rivers, 19 of them in Scotland, and the rest in England and Wales. More than 70 kilometers of riparian trees were planted along the banks. 29 stone revetment structures built in previous decades to improve the rivers were removed. On the Dee, one of Scotland's key rivers, 500 meters of earthen embankments constructed in the 1980s to protect pastures from flooding were removed in 2016. The river was allowed to meander naturally. Farmers who had opposed restrictions in 2004 gradually received compensation schemes and agri-environment subsidies for participating in bank restoration. Some of them became part of the monitoring effort themselves, recording flood events and reporting suspicious individuals on the banks. This was an unplanned outcome. The project had anticipated passive compliance. Instead, it received active participation. Some farmers who had spoken against restrictions at the 2004 hearings had, by 2015, become official monitoring partners. Their flood observation diaries entered the NatureScot database alongside scientific reports. The agricultural associations that had argued an extinct mussel could not be more important than working farmers did not change their position. The circumstances changed. The compensation schemes made bank protection economically neutral. That proved sufficient. In 2016, SIPA updated river basin management plans, tightening requirements for buffer strips between pastures and watercourses. Data gathered through the mussel projects formed part of the justification for the new requirements. Ireland, home to approximately 37% of the entire European population of the species, had, since 2009, tied its water quality standards to the condition of mussel populations across 27 river catchments. In the 2020s, Finland conducted a study comparing two neighboring rivers, one with mussels and one without. Water quality in the Mussel River proved markedly superior across standard hydrochemical indicators. The Pearls in Peril project formally concluded in March 2017. The work in the rivers did not. In 2023, NatureScot announced new data. Mussels had been found in Scottish lochs, lakes where they had never previously been recorded. The mechanism allowing them to survive there is currently under investigation.